Long wall and short wall method is the most common method of finding out the quantity of various construction items and materials which are used in construction work. The required dimensions, that is the length, breadth and depth, these are to be taken out from the drawings, that is the plan and the elevation, to find the required quantities. Hello and welcome back to the Master Civil Engineering, and in this video we will learn that how to apply the long wall and short wall method of estimation. I have been given a question which states that estimate the quantities of following items of two-room building from the given plan and the section. You can see the plan of this two-room building and the cross section of wall on this section AA. Okay, so we have to find the earthwork in excavation, raft in foundation, plinth in BCC, 2 centimeter thick dam proof course, and the first class brickwork in superstructure. Okay, first, before applying the long wall and short wall method of estimation, we have to find the center to center length of long wall and short wall. That is, we have to decide which will be our long walls and which will be our short walls for the method. So we usually take long walls along the longer dimension of the building, that is the length of the building, and short walls along the shorter dimension of the building, that is along the breadth of the building. So for this question, I will take the long wall along the length of this building, that is along this direction, and so this will give me 2 long walls, and short wall along the breadth of the building, which is along this direction, so this will give me 3 short walls. Okay, to find the center to center length of the long wall, okay, so you have to add the length along the long wall. So center to center length of the long wall, this will be equal to 4 plus 0.3, since the thickness of the brickwork in this building is 30 centimeters, so it will be 4 plus 0.3 plus 6 meter plus 2 times half of 0.3, that is from this point to this point, center of this point to this point. Okay, so this will give me the length of the center to center length of the long walls as 10.6 meter. Similarly, center to center length of the short wall, since the breadth of the room is 6 meters, so it will be 6 plus 2 times 0.3 divided by 2, which is 6.3 meter. Okay, so this is the center to center length of the short walls. Okay, for long wall, center to center length is 10.6 meter, and for short wall, center to center length is 6.3 meter. After finding the center to center length of long walls and short walls, we can now apply the method of long wall and short wall to find the required quantities. Okay, so we will do all the calculations in Excel. So let's move to the Excel to find the required quantities. So you can see in Excel I have already constructed a table. Okay, the heading of the table should be details of measurement and calculation of the quantities, and this should consist of 8 columns. The first one is the item number, second is the particulars of the item, then number, then length, breadth, height, then quantity, and finally explanatory note or remarks. Okay, so you will make a table like this in Excel. Okay, after that you will find the required quantities. Okay, so first quantity which we have to find, that is earthwork in excavation. Okay, so you have to find the earthwork in excavation. So for to find the length of the earthwork in excavation for long walls, okay, so what you will do, that is for the long walls, you will add to this center length of the long wall 1 breadth of the earthwork in excavation. Okay, so you will add 1 breadth of the earthwork in excavation to get the length of the long wall for earthwork in excavation. Okay, so center to center length for our long wall was calculated to be 10.6 meter. So to this you will add 1 breadth of the earthwork. Okay, you can see at bottom the width of the excavation, it should be 1.1 meter. So to length of the long wall you will add 1.1 meter, that is 10.6 plus 1.1, this is 11.7 meter. This will be the length of the long wall for earthwork in excavation. Okay, so write 11.7 in the length. Since we had 2 long walls, that's why I have written 2 for the number. Okay, so breadth for the earthwork in excavation, this is 1.1 meter, so write 1.1 meter, and the height or depth, this is equal to 0.3 plus 0.2 plus 0.2, which is 0.7 meter. So height or depth, this is 0.7 meter. Okay, so quantity, this will be you have to multiply these four, that is number with length, then with breadth, and finally with height. Okay, that is h8. Okay, and you will get the required quantity of the earthwork in excavation for long walls, which is 18.018 cubic meters. Okay, so similarly for short walls, okay, what you will do, to center length, you will simply subtract the one breadth of the excavation to find the length into in. Okay, for long walls you find the length out to out, and for short walls you find the length into in. Okay, so that is our center to center length of the short walls was 6.3 meters. So from this you will subtract the one breadth of the earthwork, that is 1.1 meters. So it will be 6.3 minus 1.1, which is 5.2 meters. Okay, since we have three short walls, okay, so you can see in the plan we have three short walls, that is 1, 2 and 3. Okay, so that's why I have written number 3 for short walls. So length for short walls in earthwork in excavation, this is 5.2 meter. Okay, so write 5.2. Width is same, that is 1.1 meter, and depth is same, that is 0.7 meter. Okay, so simply select these two and then drag it. Okay, then again you have to multiply, that is 3 into 5.2 into 1.1 into 0.7 to find the required quantity of uh, uh, earthwork in excavation for short walls. Okay, so select the first one and drag, and Excel will automatically calculate the earthwork in excavation for short walls, that is 12.012 cubic meters. Okay, so total quantity of earthwork excavation, this is the sum of earthwork in excavation for long walls and short walls. So simply select this column, write equaled, and then select the earthwork in excavation for the long walls, add it to earthwork in excavation for the short walls, and you will get the required quantity of earthwork in excavation, which is 30.03 cubic meters. Okay, similarly for raft in foundation, this will have the same length because we are laying the raft for the full width of the excavation, that is 1.1 meter. You can see the first one, this is the raft, which is of 1 is to 1.5 is to 3 mix. Okay, its width is 1.1 meter and its depth is 0.3 meter. Okay, so length, this is same, that is 11.7 meter. Okay, width, it will be again same, that is 1.1 meter. For depth, this is of 0.3 meter, so write 0.3. Okay, then multiply these four to find the raft in foundation for the long walls. Okay, so multiply. This is the raft in foundation for the long walls, that is 7.72 cubic meters. Okay, similarly for short walls, its length, this is 5.2 meters. Okay, so write 5.2. It's same as the length for the short walls in excavation. Okay, width, this is of 1.1 meter, and height or depth, this is 0.3 meters. Okay, again multiply it, multiply these four columns to get the required quantity of raft and foundation for the short walls. Okay, so select the raft in quantity of raft and foundation long walls, then drag it, and Excel will automatically calculate for you, that is the quantity of raft and foundation for short walls. Okay, total quantity of raft, this will be sum of quantity of long walls and short walls. Okay, so select this column, write equal sign, and then select the first one, that is the quantity of raft for long walls, add to it quantity of raft in short walls, and you will get the required quantity of raft and foundation for this 2-room building. Okay, Finally, after that, we have to find the plinth in PCC. You can see the plinth for this building. Okay, this is a two-step plinth. Okay, and the first step, this is of width 0.6 meter and height 0.2 meter. The second step, this is of width 0.4 meter and 0.2 meter is below ground and 0.6 meter is above ground. Okay, so for plinth in PCC, we will divide it into the two parts, that is the underground and the above ground, and find the underground quantity for long walls for first step, second step, and similarly for short walls for first step and second step, and above ground quantity for long walls and short walls. Okay, so first we will find the plinth in PCC underground for long walls for the first step, that is which is having the width of 0.6 meter. Okay, again, to the center length of the long walls, you will add one width of the first step, that is 0.6 meter. So 10.6 plus 0.6, this is 11.2 meter. We have two long walls, so write 11.2. Okay, its width, this is equal to 0.6 meter, so write 0.6. Okay, its depth, which is 0.2 meters. Okay, then multiply these four and you will get the quantity of plinth in PCC for long walls for step first. Multiply the first column with the second column, then with the third column, and finally with the fourth column, which is H20. Okay, so this is 2.688. Okay, this is the quantity of plinth in PCC for the first step. Then for the second step, okay, you can see for second step we have the width 0.4 meter. So what you will do, you will add, that is center to center length for the long walls, to one width, that is 10.6 plus 0.4, which is 11 meter. This will be the length of the long walls for the second step of the plinth. Okay, so write 11. Width, this is 0.4. Depth, this is again 0.2. Okay, drag the first one. Okay, or you can simply multiply these four, drag it, and this is the quantity or the plinth in PCC for the second step. Okay, similarly for short walls, these are three numbers. Okay, again, from the center to center length of the short walls, you will subtract one breadth of the first step for plinth in PCC, that is 6.3 minus 0.6, which is 5.7 meter. Okay, so length, this is 5.7, width, this is 0.6, and depth, this is 0.2. Okay, okay, then again you will multiply these four. Okay, multiply, that is 3 into 5.7 into 0.6 into 0.2, which is H23. Okay, and you will get the required quantity of plinth for short walls in the first step. For second step, again, which has a width of 0.4, so from center to center length of the short walls, subtract one width, that is 6.3 minus 0.4, which is 5.9 meter, will be the length of the short walls for the second step in plinth. So write 5.9. Okay, so width, this is 0.4, and depth, this is 0.2. Okay, then you will multiply these four. Okay, so simply drag it. Okay, so this is the quantity of the plinth in PCC for the second step, which is 1.416. Okay, after that, finding the plinth in PCC underground, we will now find the quantity of plinth in PCC above ground. Okay, so for long walls, okay, simply we have to add one width of the plinth in PCC above ground, that is which is 0.4 meters. So 10.6 plus 0.4, this is 11 meters. So for length, like 11 meters. Okay, and width, this is 0.4, and depth, you can see above ground depth we have 0.6 meters. Okay, so write 0.6, multiply these four, that is 2 multiplied by 11 multiplied by 0.4 multiplied by 0.6. Okay, so this is 5.28. This is the quantity of the plinth in PCC above ground for long walls. Similarly, for short walls, to find the length, simply subtract from center to center length of the short walls, that is the one width of the PCC above ground, which is 0.4. So 6.3 minus 0.4, which is 5.9. So write 5.9, multiply it with width 0.4 and depth, which is 0.6. Okay, and you will get the required quantity for length of plinth in short walls above ground, which is 4.248. Okay, to find the total quantity of the plinth, simply add all of these. Okay, that is the 2.688 plus 1.6 plus 2.052 plus 1.416 plus 5.28 plus 4.248. Okay, so this is equal to 17.44 cubic meters. Okay, this is the total quantity of plinth in PCC for this building, that is 17.44 cubic meters. After that, the fourth item which we have to find is damp proof course. Okay, you can see damp proof force. This is at the top of the plinth for the width of 0.4 meter and its thickness is 2 centimeter. We will find the quantity in square meters. Okay, so for damp proof course, length for long walls, this will be same, equal to the length of the long walls in above ground for plinth in PCC, that is 10.6 plus 0.4, which is 11 meter, and for short walls it will be 6.3 minus 0.4, which is 5.9 meter. Okay, so you will write for length 11. Okay, and width, since we are laying it for the full width of the plane, that is 0.4. Okay, so depth, this is already specified for 2 centimeter, or don't write anything for the depth. Okay, we have to find the quantity in the square meters, so simply multiply these three, that is 2 into 11 into 0.4, which is equal to 8.8 square meters. This is the quantity of damp proof for long walls. Okay, for short walls, okay, length is 5.9, width is again 0.4. Okay, and multiply these three again and you will get the quantity of damp proof course for short walls equal to 7.08 square meters. Total quantity, this will be the sum of 8.8 plus 7.08. Okay, but from this total quantity you have to subtract the quantity which is near the door sills, because we will be not laying DPC near the door sills, so you have to subtract the quantity near the door sills. We can see the size of the door mentioned for this building is 1.2 meter into 2.1 meter, that is the width of the door. This is 1.2 meter. Okay, so we will subtract the quantity for the door sills. So for length you will write 1.2, which is the width of the door, and it will be along the width of the plinth. So for width you will write 0.4. Okay, since we have two doors for this building, that is here and here, so that's why I have taken number for doors as 2. So simply multiply 2, simply multiply 2 with 1.2 and 0.4 and you will get the required quantity. So multiply 2 with 1.2 and then with 0.4. Okay, so you will get the deductions for this damp proof course, which is 0.96. Okay, so subtract this. So for net quantity, write equal, then select the total quantity, which is 15.88. From this subtract the deductions, which is 0.96, and you will get the net quantity of damp proof course for this building, which is 14.92 square meters. Okay, so after finding the damp proof course, the next thing which we will have to find is first class brickwork. Okay, So for brickwork, length of long walls, this will be the center to center length. You have to add that is one width of the brickwork, which is 0.3, because the width of the brickwork for this building is 30 centimeter. So you will add 10.6 plus 0.3, which is 10.9 meters. So for length, right, 10.9. Width, this is 0.3. Okay. And height of the brickwork, this is given in the cross section, this is 3 meters. Okay, brickwork is, you can see the height of the brickwork from the top of the plinth to the bottom of the slab, this is 3 meters. So write 3. Multiply these 4, that is 2 into 10.9 into 0.3 into 3. Okay, so this is 19.62 cubic meters. Similarly for short walls, okay, you will subtract from center to center length of short walls one width of the brickwork, that is 6.3 minus 0.3, which is 6 meter. So write length 6 meter, width 0.3, and height again 3, and this will give you the quantity of the brickwork in short walls. Okay, so this is 16.2. Total quantity of brickwork, this is equal to 19.62 plus 16.2, which is 35.82 cubic meters. But from this you have to subtract the door openings, window openings, lintel over doors, and lintel over windows. Okay, as I already told you, the size of the door, this is 1.2 and height is 2.1 meter. So since we have two doors, so number is 2. Okay, so length of the door, this is 1.2. Width, this will be the width of the brickwork, so it will be 0.3, and height of the door, this is 2.1. Okay, so multiply these 4, that is 2 into 1.2 into 0.3 into 2.1. Okay, so this is 1.512. Since similarly for window openings, the size of the window, this is 1 meter into 1.5 meter, and there are 4 windows for this building, that is 1, 2, 3 and 4. Okay, so you will write number 4. The width of the window, this is 1 meter. Okay, since it is placed along the width of the brickwork, so for width you write 0.3, and the height, this is 1.5 meter. Okay, multiply these 4. Okay, and you will get the deduction for window openings, which is 1.8 cubic meters. Lintel over doors, okay, we have 2 doors. Okay, and for lintel we are taking bearing 15 centimeter, that is one on the left hand side and one on the right hand side. So total width of the lintel, this will be width of the door plus 2 bearings, that is 1.2 plus 2 into 0.15. Okay, so this will be equal to 1.5 meters. Okay, width, this will be the width of the brickwork, which is 0.3, and depth of the lintel, this is also 15 centimeters, so take is 0.15. Okay, multiply these 4 and you will get the deductions for the lintel over doors. For lintel over windows, again there are 4 windows. Okay, again similarly we will take 15 centimeter bearing for lintels, so total length of the lintel over windows, this will be the width of the window plus 2 bearings, that is 1 plus 2 times 0.15, which is 1.3 meter. Okay, width, this will be 0.3, and the depth, this is depth of the lintel, which is 0.15. Multiply these 4 and you will get the deduction for the lintel over windows, which is 0.234. Okay, total deduction, this will be the sum of these 3. Okay, so write equal to, then write sum and take the sum of these 4, close the bracket. This is the total deduction, that is 3.681 cubic meters. Okay, so net quantity of brickwork, this will be equal to, write equal, this is the select the total quantity, which is 35.82 cubic meters. From this, subtract total deductions, which is 3.681. This will be the net quantity of the brickwork, that is 32.139 cubic meters. Okay, so this way you can calculate the quantities of the building from long wall short wall method. I hope this solution video was clear and you learned something new. If you find this video helpful, please subscribe to my channel and share this video. And also, if you have any doubts, you can write them in the comment box and I will try my best to solve your doubts. Okay, thanks for watching and stay tuned.